You use division to rename a fraction as a mixed number.
For today's math lesson, 5th grade teacher Hayes Dabney has planned a lesson that differentiates content. All the students are working on the concept of fractions, but they are at different levels of understanding and working with fractions. So the teacher has organized students into 3 groups that will focus on different aspects of fractions.
So the whole goes as a whole in the fraction, and then the remainder goes for the numerator, and the 4, which what you divided by is
Divisor.
the divisor would be the denominator.
Content can be described as the facts we want kids to learn, the skills that they need to master, probably more importantly, the concepts that govern a field. So differentiating content really means matching a starting point in the content with the child's readiness level, with the clear view in mind of moving them along as quickly as they can move and as deeply as they can move, but in accordance with their own individual needs.
Read this. What are we going to do?
Students who are struggling with fractions are working on understanding whole-part relationships.
So what did you do? What did you do first in order to come to that conclusion?
I thought about the last one that you showed us. The last one, it was different. It was the whole was 8, but you said 1/4, and you broke the square up into 4 parts and took one of them away.
Okay.
And that's how I used that to give me an answer.
Because you built on that new information. Good.
Students in another group have mastered the concept of whole and part. They're now working on understanding equivalent fractions.
Mohammed?
1/2, 2/4, and 3/6.
1/2.
2/4 and 3/6.
And why do you say that?
Because they just have the 2 has only 1 colored in, so that's half. 4 has only 2, that's half of 4, and 6 half of that's 3. And there's lots of numbers you could get.
Students who have a more advanced understanding of fractions work with mixed numbers and improper fractions.
Over 6, okay? And you have to say how many 6 goes into 47. Yeah, 7 times.
For number 8, I got 7, 5, 6.
5, 6? Yeah.
6. 5, 6.
Okay. I got that one totally wrong. I got 5 and 2 9s.
You have students that work at different levels of competency, and if they are challenged at those levels, then they're more likely to enjoy the learning that goes on in your classroom. Ashley?
10/5.
Because some students are at a more sophisticated point of learning and others at a more basic point, it's important to present the task at sort of multi-levels. And one way of thinking about that is thinking about the task on a series of continuums. For example, some students might need a very concrete learning experience where they can use manipulatives, see with their eyes how something works, whereas a group that is more sophisticated or more advanced with that same concept might be ready to work from a point of abstraction. Some students might need a task that has very few directions in it because it's difficult for them to sequence and to follow many directions. Other students might be ready for a task that has many steps or many directions in it in order to provide a challenge. And what you're trying to do is to push each student just a little bit further than they're comfortable going so that they actually have to draw on all that they know and yet experience a little bit of a challenge and a sense that when they finish, they've done something that was important.
So you have how many counters?
9.
You have 9 counters. So we took the whole, what we knew. What we knew was that rectangle was a whole. We knew the fraction that we wanted to work with, and we took what we knew to find the part.
Struggling learners are working with a concrete task, working more toward the concrete end of the continuum, with a task that enables them to see, to observe, to touch the main idea, so that they get a chance to manipulate parts and wholes and see how parts come together to make wholes. Students who are roughly on grade level in this class are working with equivalent fractions. It's a little bit more toward the abstract portion of the continuum. They have the opportunity, if they need to refer back to the concrete experiences, have some diagrams and things that they can work with. But the notion of equivalent fractions is beginning to take shape in their head more from the sense of what the number abstractions look like than the concrete manipulatives. Students who are more advanced in this particular concept already have the notion of part and whole, and they already have the notion of equivalency in fractions. So what the teacher has done is to move them fairly far over to the abstract end of the continuum and involve them in working with non-equivalent fractions. That means that they need to understand the abstract principles, understand how the abstract principles operate, and manipulate those in situations that are a little bit less predictable.
And if those equal 2, and there's 1 left out because that's not a whole number, it's just a fraction. So that would be 2/3. So that would be like 2 plus 2/3 equals 2 and 2/3.